Okay, I mean, we skipped whatever we did before, but we'll start from here. So this one is easy. You're basically saying this triangle is plus this triangle is going to be the rectangle. So this triangle is half of the rectangle. So this is the base simple one. But even for this, you actually need to physically, you can't do it in GeoGebra. You have to actually physically make it and cut it in two. So when you physically make it and cut it in two, you can line it up on top of each other. So then that becomes much better. Then the next is, of course, that this one is equal to this one. And this one is a little harder for like to convince children. And I mean, many of them will get it if you just say, let's just sort of split it in two and it's obvious, right? If I split this in two, if I cut it in two pieces, then this was a rectangle and this is a right angle triangle inside a rectangle. This is a rectangle and this is a right angle triangle inside a rectangle. So because this is half of this and this is half of this, together this is half of that. Now this argument somehow I have not seen it fly very well with children. I don't know what is the gap in, but from what I said, I'm sure you all agree with the argument, right? So that's the proof. The formal proof is that you split it. You create a new picture in which you split it in two and then say, hey, this whole thing is a rectangle. And this guy is half of that, as we have seen before from here. And this guy is also a rectangle and this is half of that, as we have seen from before. So you're adding the two together. So the bigger shape is twice the green shape. Okay, but yeah, so you have to spend some time doing it a few times with many different rectangles, and the best is to actually have them cut it out and place it on top so that they are convinced that this is actually true. If you were to make material, you could make it out of cardboard and you could have these drawn and those two pieces separately cut out so you can place it there and here and convince yourself that it's the same. So this is the second kind of triangle, and the third kind of triangle is the obtuse triangle. So you get where I'm going with this, or would you like me to draw it?
Draw the third triangle, obtuse.
Okay, fine. Let's do that also. Yeah. So so again, the same thing. I'm drawing lines. So I'm going to draw this, and I guess it's going to see. So basically, the point is, as long as the base is the same, right? Even if I have a triangle that looks like this, right? The triangle has the same area.
Same area.
Yeah. So that's basically what we are attempting to convince children. So as long as the base is there and the height in these two, it actually encloses. So the sort of definition I gave is true only for the acute triangles, in which basically you have a base and the rectangle encloses the triangle. Then the triangle is half of the rectangle. Now this one extends that area. And this talks about if you have a rectangle that has the same height as a triangle and the same base as the triangle, then the area is still half of the rectangle. So this is sort of a next stage sort of thing. Who is having difficulty with internet today? Some people, people have joined. Yeah. Hello. Okay, so we continue. So this one proving is sort of the next step, which is basically you have to, you need to have an additional box, an additional rectangle, and then in that additional rectangle, you are going to have this triangle, and then you're going to say, okay, for this rectangle, this triangle is half of that rectangle, and this triangle fits into this bigger triangle very neatly, and so on and so forth. So this actually requires a little bit of subtracting triangles and convincing people that it's similar to having a big rectangle in which this is half of that, and out of this, I am removing the red one. Okay. So in case that was very unclear, I'll just draw it again. Okay. So the first rectangle I'm talking about is the red rectangle, which is a big rectangle. Yeah. And the right angle triangle inside it, which is basically referring to this. Right. From here, The right angle triangle is half of the big rectangle. Is that clear? Okay, I'm going to hope it's clear. And then I'm going to consider the smaller rectangle, which is outside. And I'm going to say that this triangle is half of that rectangle. So when I remove from the bigger one, the smaller one, which is the same as from the bigger rectangle, the smaller rectangle, we get back to this rectangle. I should use a different color. We get back to this rectangle, bad color. So this rectangle is what is left when you subtract the, well, similar colors, but let's say from the red rectangle, I subtract out magenta, I don't know what to call it, that rectangle. Then I'll be left with the blue rectangle. And when I subtract out from the red triangle, this other triangle, I'll be left with the blue triangle, which then must be the half of the original rectangle. So that would be where I would go from here. I mean, I would start from here, but I would move there. That would be what I would do. Does that make sense? Vasantraj, does that make sense? So I would actually start from here. I would start from this and then draw it out. And then you get into the pattern of drawing rectangles and then drawing squares and then move from squares to graph sheets. And then from graph sheets, you can move to all these other cool things that you would like to work on. More complicated things that you want to work on. Right, and from that, you can move on to the geoboard. A geoboard, Sundar, geoboard has two sides. The second side actually has circles. It has circles and small pieces. Yeah. So you can also use that. You don't only have to use the regular geoboard and make something of its own. You can use the geoboard itself. Okay. All right. So I've talked about. So the other thing I had talked about before some of you joined was basically using Jodo cubes to make 2D structures, so children can draw it and get the sense of. You can start with even neat rectangles and get the sense of how many cubes you used, and then sort of move it into, if you placed it down, how many squares are you using, so that you extend the concept. But you can do things like volume very nicely with this, because now you've made the shape, right? Or even if it was a more condensed shape, you can talk about, as you keep getting more layers, you are going to multiply it by height. How many cubes have been used? If I had 2 layers of this, would actually be the volume, which is how many cubes. Not how many squares do you need to cover it, but how many cubes do you have when it is 2 floors, and when it is 3 floors, when it is 4 floors. So you can even get to volume from this. And then the idea that pi r square is the area of a circle, and so when you multiply it by the height, you're getting volume will become more obvious. So this is a nice way to extract that. Does that make sense? Hari, I think you were working a little bit on it, but not quite this.
Yeah.
Do you get what I mean?
Yeah, I can understand.
Okay. So you can start with things that are the easiest, which is come back to rectangles, come back to squares, come back to simple multiplication, and then go to the more complex things like circles and so on. Yeah. So let's talk about circles. Okay. So see, one of the activities is to get children to just make a circle on the ground. So like you'll ask, what do you need? Say, okay, here, I'll give you this, and you draw with this the circle. Is it enough? And you say, no, it's not enough. So then you'll probably go out and you'll get yourself a thread or something like that. And then you'll basically have a center, and you'll make a circle around it. So then you ask, which of these components, without it, is it possible to make a circle? Without the center, is it possible to make a circle? Without the string, which is constant, is it possible to make a circle? Yeah. So then you get the concept of radius and center and all from that. And then you can do an exercise in which you measure circular shapes and measure the diameters and see if the ratio is the same. But it takes a lot of time, and many times the measurements are not accurate, especially let's say if you're measuring a tree, right? So the question is, I want to measure the tree, I want to measure its diameter. Am I measuring the diameter of the tree accurately? And so then the question comes, okay, you need to place 2 planks that are parallel to each other. But then if you place it like this or like this, you start getting errors. Then someone will say, okay, like, can I measure my bangle? And then they'll say, can I measure my ring? And what happens when you go in those along those lines is that the measurement, the accuracy of your measurement needs to be really good. Otherwise, you will not do justice to pi. You get what I mean? So you can get a sense. You can get a sense of things by just taking a string and then taking a string with a diameter, let's say with a bangle, and saying it's more than 3 times. But I actually prefer an activity. I cannot minimize zoom when I'm recording. Yes, I didn't mean to do that. I meant to do this. Where are you? Okay, but you can do the activity very nicely uh, with basically GeoGebra. Yeah, and I'm going to save as code was. Okay, so you can just get children to draw a bunch of circles. So you get a center and you draw a circle, and you draw circles of different sizes and whatever. And they can just have fun with it. And then they can, among the tools, or maybe options window perhaps. If it wasn't hung, I could do it. Nice. Views, perhaps, yes. So under views, you can also have spreadsheets. So you can, whoa, this is a big one. Oh, good. Okay. So you can have a spreadsheet in which you basically go ahead and you can put like if you wanted to do perimeter or you wanted to do area. So you can say what's the radius, or you can say what is the diameter. That's up to you. This is radius is more obvious here, obviously. So what is the radius and what is the perimeter? And then you can go into the measuring tool. You can come back here and you have a fairly nice tool for measurement in GeoGebra, which makes things quite nice. So let's say you take distance, and you basically are taking the distance from here to here. So it says, okay, AB is 3.91. Yeah. Of course, there are clever things that they can do. They can refer to the variable and so on. But let's say right now they don't do that. They just put 3.9. And then you can say, okay, let's measure the perimeter. So you can come back here and then say, okay, I measured that. Yeah, I measured distance. If I just click on that, it will give me the circumference, perimeter or circumference. So they say, okay, that's 24.57. And then you can, talk about what is R square, what is it, different things you can do. Perimeter is simple in this case, of course. So you just say, what is the ratio? And this is also getting them comfortable with Excel, which some of you, I'm sure, use quite a bit. And so you get some value. And then you basically do it for another circle and another circle and another circle. And you start noticing that the same pattern, the 2 pi is coming again and again and again, right? So I'm just showing you a little bit of that. You can, of course, do it a lot more. And then, yeah, if there are some really clever characters, you can, okay, fine, why not? Then you say, okay, just draw a line, right? You get a segment, and then it already tells you what is the length. This is 7.08. So can I just put F here instead of doing all this work? And yeah, you can. So that's great. So then you say, okay, go back and, so I mean, you can get clever about it, of course, but that's okay. It's just a matter of how much you know the tool and stuff. Yeah, so it's come up with circumference. So is there a way to just call the variable here? Maybe a way to call the variable here and so on. Yeah. So F is gone away. It's there now. Okay, somebody's saying something they can't see. Chat. Why don't we use vernier caliper to measure small circular materials with accuracy? Yeah, we do have those instruments as well. and still the accuracy is not good enough. If you think about the kind of accuracy you require for pi, okay, you use a vernier caliper. The question was, why don't we use a vernier caliper for small objects? Yeah, that's great. So you're going to measure the, let's say, diameter, which also is a little hard because you need the inner diameter, you need to get it just right. Okay, let's say you even managed to get the diameter right. Now, how do you get the circumference right? Right? So to get the circumference right, you have to get the string right around it, and then the string will keep slipping. Yeah, I mean, I've actually done it, no? including measuring the capacity of our tank. So anyway, you can do it and see, no problem. Okay, so you can actually get things rather accurately. And then they can also learn something else beyond that. Oops, what did I do? So for C, I put this object is called something else. This circle is called D. Yeah. So anyway, you will soon get a sense. All I'll say, Hari, is that yes, you can. You will soon get an idea of how much time any activity takes. So doing an activity in which children have to draw in GeoGebra and say, okay, everyone go out, draw 10 different circles and get me the ratio, the table of ratios. You can take 10 minutes and you can have like 100 circles that children have drawn. I mean, 10 children in a class, 16 children, 160 circles you can draw, and you can get a number. But if you ask them to do an activity with the circle, the entire class will go. So about 1.5 hours you'll be spending on that. Then you will have to talk about accuracy, because it's very interesting. And if you've done some a measurement accurately like this, which will not have any errors, and then you move into something like a real experiment where you're going to have errors, you can talk about errors, which is very cool. But if you don't know what is expected and you get into real measurements, then it gets really messed up. But anyway, I have a note on my blog. Small is beautiful. You can go take a look at it when we had done it, and that might give you an idea of what all you will get. Because I've actually put the table we get, the Excel that we got. But all I'm saying is all of it is available in GeoGebra, and you can actually explore different ways to look at it. So one of the things you're doing in GeoGebra is you're looking at exploring this by looking at an image. You're looking at exploring it by looking at an equation. Right? I don't know, some of you may not even remember that the equation this is what equations look like for circles, right? The square of the x, square of the y with the center, x minus x1 whole square plus y minus y1 whole square. So implicitly, all these things start coming in the side. So all you need to do is just direct them in that way and say, okay, which of these circles is which? And soon they'll get an idea that, this has to do with, this is bigger for this. This is the smallest one, it must be the smallest circle. This is the biggest one, this is the biggest circle, and so on. And then you can start exploring, okay, what is the relationship really between something that's 50 and something that's 7? Is there a relationship between them, right? Is there a relationship between, so and so on, right? So you can get a sense of this. You can even draw nice circles after that. You say, okay, to get a relationship, we'll draw neat circles. We'll draw circles of radius 3, 4, 5, 6, and see what the equations look like. So the nice thing about GeoGebra is about patterns, and you can see it in many different ways, which I think is cool. Yeah, okay. So I'm going to pause GeoGebra at the moment. Are there any questions? There are no questions. It's all very obvious. All right, wonderful. Okay, so rectangles, is it possible to make circle is done, Quizna rod is done, Jodo cube is done. Rectangles are done, GeoGebra activity is done. Okay, fine. So next, let me get to algebra. Okay. So what I was seeing under algebra, what some of you were doing, and so I had a question about that. Let's see, where are we? This is a slider. Where do I add text? Insert. Edit. Huh. How do I add text? I know it's there and it's very cool. This thing is saying text font. Maybe just T. No, that's not it. It doesn't work. Okay, rename. Fine. Anyone who has used Geogebra, how do I insert a text? Labeling. Is that it? No.
Can I share your screen? I can tell you.
You can tell me here. No? Oh, am I not sharing my screen? Sorry. Yeah. Go ahead.
Click on the second one from the last, the slider.
Yeah. Oh, there it is. Very good. Okay. So what I would like to talk about is, let's say something like this, right? So I'm going to assume that you already. How do you make it bigger? Font is it? This way. Right. So you already have something like this. Okay. So and if you, this thing allows latex equations. So actually you can make it quite nice looking. So you say it's a latex formula, and then you say, so it will look a little like it is in the book, which is quite nice. So now the question is, if I want, what is the story each of you have been telling children about this? So I understand the story for something like, right? So, oh, I should have done latex. But how come 2x comes so nicely there and so horribly here? That was weird. Okay. I'm failing to see why he thinks this is logical. But anyway, must have got something wrong. Okay. Doesn't matter. We'll figure that out. Technical issue. So the story for 2x equal to 8, and let's say a story for x plus, 3 equal to 5. Now, these are stories that you've probably been ramping them up on quite normally. So my question is basically with regard to, okay, the combined story. What do you do with a combined story? 2x plus 3 equal to 5. So who all said algebra? Let's start with you. So 6th grade, Madhavan, what's your story for 2x plus 3 equal to 5?
X plus 3 is equal to 5.
See, in order to understand mathematics, you need to either A, be able to express it as an image, B, be able to tell a story about it. You can draw it or you can talk about it. So once I can draw and talk about it, I become comfortable with it. I become familiar with it. So this is one of our goals. How do we make children comfortable with mathematics? Yeah. So what is the story I'm telling for 2x plus 3 equal to 5? It's a single variable story. So what are you telling them? Okay. Murli, what are you telling them?
Plus 3.
Okay, 6th class is done, 7th class. Puri, what are you telling them?
There are 5 chocolates.
There are 5.
There are 5 chocolates,
Okay.
and my sister has 3 chocolates.
Okay.
And how many chocolates times 2 should I have?
All right. Okay. All right. Well, at least it is telling the story of this. That's fine. All right. Who has a 7th grade? Siva, what's your story for this? Okay. Let me ask you a different question, Puri. 2x equal to 8. You will not say 2 times what I should have to get 8 bananas, right? You get what I mean? Yeah. Anyway, think about it. Think about it. All right. Siva. We can't hear you, Siva.
Uh, Two offers are 5 rupees, and they are giving offer. If you buy 5 rupees, then they will return back 3 rupees. Like,
Okay. Fine. I mean, I see. Basically, 2x equal to 8, you're trying to extend. 2x
Yeah.
equal to 8, you would have told children, I have 2 bananas. They are 8 rupees. How much is a banana, right? What's the cost of 1 banana? Yeah, so we have.
so I'm
if you
trying
have-
to get 2x equal to 5 minus 3. That
I get it. I get it. Yeah, I mean, that's, yeah, it's just that the final story that came out sounded a little hard for a child to understand. But that's okay. I understand. I get what you're saying. Okay, who has a 7th grade? Meghanajan, would you like to suggest something?
Yeah,
Go ahead.
I also tell like a previous guy the banana you have a 2 banana and the
Yeah.
rupees is 8. I think
Yes.
about it. Just like
Yeah,
I'm
yeah.
also thinking.
I agree, and I think that's fine for this one. What about this one?
2x plus 3. Are you?
Yeah, 2x plus 3 is equal to 5. Story.
Um, kind of story I want.
Okay, fine. We are going on to the 8th grade. 8th grade, hurry, let's go.
I want to think about.
Yes, I understand.
Yeah.
That's why I'm asking Hari. Yes, Hari, go ahead.
Yeah. We have money of the 5. Money of 5.
Yeah, okay, you have money 5 rupees.
I have balance of 3.
Balance of 3, yes.
This is 2 is a banana price or something.
No, there are 2 bananas, let's say. Okay, I bought 2 bananas.
Okay.
Right. So I had 5 rupees. I took 5 rupees to the shop.
Yeah.
And
I have a balance.
I came back from the shop. Let's not call it balance yet. I came back from the shop with 2 bananas and 3 rupees.
Yeah.
So you don't even have to use the word balance. Children will figure it out that it's balance.
Okay.
Right?
Okay.
So I came back from the shop with 2 bananas and 3 rupees. How much was the cost of 1 banana?
Yeah.
Right? It's amazing that most kids get it right. You don't have to tell them that to solve it, this is plus, it needs to be taken to the other side and make nothing. You don't have to tell them anything. You don't have to tell them anything. You just say 3x plus 8 is equal to whatever you want, 17. And you tell them that, you go to the shop with 17 rupees and basically you buy 3 bananas or
Buy 3
whatever,
bananas.
and you have 8 rupees left. So what was the cost of 1 banana?
Yeah.
They will immediately do 17 minus 8.
Yes.
That is the
Then
first
after-
thing they will do. Then
after
they'll
that,
divide it. Then they'll divide it by 3.
Yeah.
So I've actually not seen any kids get this wrong. If you tell the story like that, if you give them the equation, a lot of people will get a lot of things wrong.
Why?
But if they do, I mean, they'll probably subtract by 3 instead of subtract by 3 instead of divide by 3. They'll do all kinds of things because it gets messy. The 8, they wouldn't know what to do when you take it to the other side and so on. But if they understand it as a story, and this was one of the stories that the children told me, and I've been using it since then, it just works. So the story of taking some money with you and then buying something and having something left works very nicely for an, of course, addition story. Yeah. Okay. That's great. All right. So I wanted to bring that up because one of you were discussing that in your session. So algebra stories, the division story, the subtraction story, and the combination of the two, how do we put those together, I think is crucial. One more thing I would like to do when we are doing it, this is a single variable, I want to go to 2 variables. And again, something that they can draw out and otherwise, like, oh, I wanted to clear everything in Geogebra. I shouldn't have done that. Okay, and this is sort of where I like this. Yeah, go ahead.
Sanju, can you hear me?
Yeah, I can hear you, Sundar.
Sanju, we also made a scratch program, right, with the weighing scale to show that whatever is in the left side is equal to the weight on the right side. So, but you can also use money, for instance, or you can also do the weight.
That's a good one. So let's actually stay with that then, yeah?
So I have 2 melons on the left side and 3 kilo stones, and on
I
the right side
understand.
I have 5 kilo stones. And what is the weight of the melon?
Which is the next one. So let me stop sharing screen for a minute. Can you see? Okay. So this one I call algebra with a pencil box. Okay. So basically, it's amazing how many children will have exactly the same looking things, right? So let's say you have these 4 erasers, right? And so these are, by and large, they're about the same weight. So what do you think is the weight of an eraser? So you can start with the question as simple as that. What is the weight of an eraser? And you ask them to write it down. So all of you write it down. What's the weight of an eraser? So of course they'll say, no, I want to feel it and so on and so forth. And now we cannot do this in Zoom. There are limitations in Zoom that we are finding. So here, if you can, there's no way to turn on. So anyway, this is it. Yeah? Okay. So has everyone written down? Okay, let's go. If you've written it down, let's go one by one. Arvind, what's the weight you wrote?
I wrote actually 50 grams.
Okay, Bhagyalakshmi. Bhagyalakshmi Palanivel. Yes, go ahead. Wait.
Hello.
Yes, I can hear you. The weight of one eraser. What did you write down? I asked everyone to write. The rest of you, if you have not written it down, write it down. Otherwise, this is what will happen. You'll try to guess at the moment. Everyone, please write down a number in grams, not in kilograms.
100 grams.
100 grams. All right, fine. Hari is next on my list. Hari.
20 grams.
20 grams. Okay, Madhavan.
70 grams.
Okay, Meghanathan.
It's around to 30 something.
30 grams. All right. Murli.
15.
15 grams. All right. Who's next? Puri.
25 grams.
All right. Ranjit.
10 grams.
10 grams. Okay. Sarvanan.
20 grams.
20 grams. Siva.
25 grams.
Okay. Sundar and Vasant.
50.
15.
15. Okay. So then you can basically bring into your classroom something that we all have in all the STEM lands, which is a weighing balance. Yeah. Now, if you want to get all cool about it, yes, certainly we also have, or we may not have, which we should have, the very nice digital balance, which will measure up to a gram. But and of course, with something like this, you need to make sure that your instrument is okay. So yeah, it's not all tied up as it is now. So you need to take care of things and stuff. So you might have to unhook it and hook it and so on. But basically, if you hold it in the middle and you have to see if it really balances out, you might not be able to see very well. Maybe if I make it a little straighter, it will help in this one. Yeah. Okay. So is it sort of centered? You can look at that. And one of the things you can use, of course, you can use weights, which is like this, right? And you can also use like rods, and you can use the fact that your Dynus cubes are actually 1 gram each. So you can use this for the 1 grams. Yeah. So now you talk to them about error, right? I mean, we've talked about error in the past. That if you're going to make a measurement and you're talking about grams, it's easy to get the weight of one of them wrong. So you start basically, I don't know the weight of one of them, but I'll measure 4 of them. That seems reasonably heavy. We should be able to weigh that. And that the error should be a little less. And then we'll try to compare. Yeah. Then we'll try to figure out what one is. So that's the same question. And you can do all these things with the pencil box. And then, of course, you can add stuff that you know the weight of, it doesn't balance. And you can create all kinds of limitations and so on. So let's see. Okay. And see, the other thing is that you're all curious now. What is the weight? Because you've guessed, no? So the longer I'm taking, you're like, why don't you just measure it and get it over with? So that sort of feeling should be there. The children are like, come on, get on with it. Right? I know I'm right. So and so on and so forth. So I basically put 4, right? 4 erasers. And then, of course, you do drama. And you say, okay, what is this weight? Okay, so, this one is, I can't really read. I'm getting old. 20 grams. Okay, so I'm going to measure it with respect to 20, and that's no fun because nobody's weight is that. Okay, so let's say I'm going to measure it. What else do I have? I have 10 grams. So that's 30 grams, 40 grams. Okay, so if it was 10 grams, it would be equivalent to 40 grams. So let's measure this and see which side is heavy and which too bad. Okay, let's put 50 grams. Okay, so if I put 50 grams, 50 grams is heavier. So wait a minute. This is not really heavier than 12 grams. Yeah, interesting. So 40 grams is even Steven. So that means the weight of one eraser is 10 grams. Okay. Now this was the easy version of it. But anyway, you get the picture, right? How many people said 10 grams? I think someone said 15. I think Vasant Raj or Siva said 15. I couldn't make out at the time. 1-5, right?
Me and Murali said 15, but Ranjit said 10.
Ranjit said 10. Oh, there you go. So someone got it right. So the eraser is about 10 grams. Now the cool thing about this is it's stuff that children have in their pencil box. They're bringing it in every day. Yeah. And you are basically connecting it with something they use. And many of them will have something similar. So it's not that one pencil box. You don't need to be an Arham. You'll have a lot of these. Yeah. Every few days he'll go in with a bunch of them and he'll come back without any of them because he would have distributed it to everyone. So even then you're going to have enough of these to sort of the pens that children use, they may be similar. And then if it's not similar, then they'll talk about it and so on. And then it can become a fairly interesting session. And then you'll have things like, they'll say, what's the weight of a piece of paper? And so what is the weight of a piece of paper? One A4 size sheet, what's its weight? So you get them to always write it down. Otherwise, what they'll do is they'll say something and then they'll say, I said something else. Now, whatever is the right answer, that's what I said. I was thinking that. Otherwise, they won't say that I said it. They'll say, I said it, but I was thinking that. So you get everyone to write down. Okay, we write it down. And then and now we think that's okay. So let me give you not a counter example, but how to think about it. Many of you may have held the rim of paper. That's like thousand sheets. You must have held that thing in your hand, right? So how did it feel? How heavy did it feel? Now, since Sundar handles our paper, I'm going to ask him first. Sundar, you know what I'm talking about, the A4 big bulk thing that we buy, right?
Yeah.
So how heavy does it feel?
Well, usually it has the rating, right? I just can't.
Yeah, but the rating is not necessarily in grams. It's in thickness,
Oh,
in square mm thickness. There is a square mm weight, but square mm weight, what are you going to do with for a sheet of paper? That means you need to multiply it by its area. Area of the sheet, no one knows. You know, I mean, you're not Swati, so I can guess you will not know. Swati will immediately tell you, oh, area, I know. Like that. Okay, fine. What is the area of an A4 sheet? If you're going to multiply it, you're going to see complicated things of multiplying it by.
210 multiplied by 297 mm.
He's coming up with. Here we are debating about whether there is God or not. This person comes along and gives us his phone number. That's not okay. All right. Where are you getting this from?
internet.
That's not fair at all.
I was just kidding. I was just joking.
Right. So that's the other thing. So the internet is not always good for stuff. I mean, it is good for stuff because it may not have the kind of paper we have in India because much of the data that comes in internet has to do with the US. So they may be talking about a nice letter, thick, that one, blah, blah, this, all kinds of things. So anyway, let's go back to that thought exercise. How heavy does a rim of paper feel?
No, to 2.5 kilos.
5 kilos.
I said 2.5.
Okay, fine, 5 kilos. Anyone else has held a rim of
I said
paper?
2.5.
2.5 kilos. Okay, multiplying what he said by 1,000 gives you 2.5 kilos. I understand where you're coming from. Okay, very good, very good. Anyone else has held a rim of paper?
Yes, Sanjeev.
How heavy does it feel?
I'm also heavy in 2.7 something. I see in cover of the paper.
Oh, in the
college
cover
paper.
itself it is written. You have read
Yeah.
it. Wonderful. So this is also great. If it gets people to start looking at the covers, right? Then that's actually great. The children start reading what's in it. Like when they buy a shampoo packet, they should know what is the weight of the shampoo packet. It gives a sense because you're carrying it with you. How heavy did it feel? So then they start looking around and, it's like, okay, you go to a notebook and say, well, how heavy will this be? Anyone taking guesses?
180 grams something. Your long size note or shortest note?
Well, what does it look like to you? This is a long size note or a short size note?
Short. It's
Yeah,
90,
it's something in the middle. Something in the
90 or
middle.
something.
Let's see if it has its weight on it. It has a size on it, 24 by 18 centimeter. Does that help you? And then it has 172 pages. Does that help?
No.
No. So how do you get, like, by weighing something, what is its weight? Can you compare it with what it weighs like? Like, you can have these conversations. I'm not having this conversation with you. I'm asking you to have these conversations with children, right? And how do you compare it with, let's say 20 grams and how it feels? And is it really like, is the feeling the same? Or because this is concentrated, you will not feel the same this side and that side. So you should make it flatter so you can get the same feel because the pressure is not the same, right? So these are questions we can have with children to start developing a sort of sense of connecting it with what they are doing around you, which is one of the things I've given as a general feedback. So yeah, Sundar, absolutely. You can not just a Scratch program. You can start with this, and then you can do it in Scratch. And we have many other projects also like that. And there's even a website that many of the kids were solving. They have a lot of puzzles in which they have to equalize two sides, right, Vasantra? What is it called?
Solve me.
It's just called Solve Me. Solveme.com, is it?
.org.
Solve Me. So some of these things come in basically mobiles. I don't want mobiles. I just want to start. No, this is not the one. Solveme.org, is it?
Yes, Sanjay.
Okay, it didn't come up on Google. So there you go with Google. So this book that we are getting from that Swati edits called At Right Angles. So all this has, some of this has come in that, this solveme.org and all has come in that. So wow, they've actually done it in a different language. Anyway, it doesn't matter. So I didn't find the website, it wasn't coming up. But there are puzzles, there are lots of puzzles. And there's someone solving it that came up in YouTube and he's sort of explaining in, I think, Russian. So, and stuff like that. Yes. All right.